March 17, 1943. The Luftwaffe testing center at Recklen, 60 miles north of Berlin. The morning air was bitterly cold and carried a sharp metallic edge. Inside a vast hangar, 500 of Germany's most brilliant aviation engineers stood in complete silence, like statues, like ghosts frozen in place. Before them rested a Boeing B-17 Flying Fortress, captured 3 weeks earlier after an emergency landing in occupied France. The bomber was almost completely intact. Its crew had been taken prisoner, and the aircraft itself had been transported under heavy secrecy to Germany's most classified testing facility for detailed examination. The order had come directly from Reichsmarshal Hermann Göring. Find its weaknesses, he had commanded. Discover how to destroy these American bombers that were beginning to appear over German skies in ever-increasing numbers. Prove that German engineering was superior. Restore confidence in the Luftwaffe's ability to defend the fatherland. The first man to approach the aircraft was lead engineer Friedrich Koch. He was 47 years old, a veteran of the First World War, and a respected designer who had worked on components for the Heinkel and Messerschmitt aircraft that represented the pride of the Luftwaffe. He carried a clipboard under his arm and wore the confident expression of a man who fully expected to find crude American workmanship and careless construction. That expression lasted for roughly 7 minutes. Koch climbed into the bomber through the waist gunner's position and came to a halt. His hand reached out and touched the interior aluminum skin. Slowly, carefully, he ran his fingers along a line of rivets, then another line, then another. The color drained from his face. He called for his assistant, his voice tense with something that sounded dangerously close to fear. "Bring the measuring instruments," he said quietly. "All of them, and bring the metallurgy team immediately." By noon, Friedrich Koch understood that Germany had already lost the war. By evening, all 500 engineers understood it as well. Within a week, Koch would write a report so devastating in its implications that it would be classified at the highest level and buried for decades. This was the story of the day German engineering confronted American mass production and realized it was fighting not just an enemy, but the future itself. For 4 years, Germany had perfected the art of strategic deception. By 1943, Nazi propaganda had successfully convinced both the German public and much of the military that American industrial power was largely a myth. Yes, America was large and wealthy, but wealth did not automatically mean technical capability. The Americans, propaganda insisted, were skilled at producing automobiles and refrigerators, not precision machines of war. They had no tradition of master craftsmanship. They built in quantity, not in quality. German engineers believed this without hesitation, and they had reasons too. German aircraft such as the Messerschmitt Bf 109 and the Focke-Wulf FW 190 were masterpieces of mechanical perfection. Their components were hand-fitted. Their parts were machined with extreme precision. Final assembly was performed by highly trained craftsmen who treated each aircraft almost as a unique creation. Every plane was, in many ways, custom-built, with individual adjustments made by experienced technicians. This was a German philosophy: thoroughness, precision, excellence. A single Messerschmitt fighter required roughly 1,500 man-hours to build. This was considered entirely acceptable because the finished product was superior. Quality over quantity. Always, the Luftwaffe High Command knew American bombers were beginning to operate over occupied Europe. Reconnaissance photographs confirmed it. Fighter pilots reported encounters. Yet the reports were contradictory and confusing. Some pilots claimed the American bombers were truly flying fortresses, nearly impossible to shoot down. Others insisted they were vulnerable, merely more numerous than expected. Göring dismissed the more alarming accounts. "American bombers are propaganda," he declared. "Large, crude, badly designed machines that will collapse under sustained attack from superior German fighters." Still, he needed proof. He wanted his engineers to inspect an American bomber and confirm what he already believed. The captured B B-17F had belonged to the 303rd Bombardment Group and was named Ruthie II. It had completed 8 combat missions before being forced down by engine failure over northern France. The aircraft had made a belly landing in an open field. The crew attempted to destroy it before capture, but German troops arrived too quickly. Several systems were damaged, but the airframe itself remained structurally intact, making it perfect for examination. The bomber was transported by rail to Rechlin, hidden beneath heavy tarps, and moved only at night to preserve secrecy. When it reached the test center, word spread rapidly among the engineering staff. An intact American heavy bomber was now available for complete and unrestricted analysis. The engineers arrived expecting to find an oversized, roughly assembled aircraft, a product of American industrial carelessness. They anticipated weaknesses that could be exploited. They expected confirmation of German technical superiority. They found none of it. Friedrich Koch made his first disturbing discovery within minutes of entering the aircraft. The rivet work was extraordinary. Not good, not merely acceptable. Extraordinary. Every rivet was identical. Every rivet sat perfectly flush with the surface. Every rivet was positioned with mathematical precision. This was not hand riveting. It could not be. The level of consistency was beyond what human workers could achieve. Koch measured the rivet diameter, 0.40 inches. Every single one was the same. He measured the spacing, 0.75 inches from center to center. Every single one matched. He examined hundreds of rivets across multiple sections of the aircraft. There was no variation. None at all. "This is machine work," he said quietly to his assistant. "But how?" The fuselage was curved, continuously changing its shape along its length. How could a machine place rivets with such precision on a surface that was never flat? How could automated equipment adapt to such complex geometry? His assistant had no answer. The examination widened. The team moved methodically through the entire aircraft, section by section. The bomb bay, the cockpit, along with the gun positions, and the tail section. No matter where they looked, every component revealed the same impossible truth. This aircraft had been mass-produced to tolerances that German custom-built aircraft could not achieve. The aluminum skin panels were stamped, not hand-formed, yet the stamping was so precise that every panel was completely interchangeable with any other of the same type. A German engineer named Werner Hoffmann decided to test this. He removed an aluminum panel from the left side of the fuselage and carried it to the corresponding position on the right side. It fit perfectly, without adjustment, without force, as if it had always belonged there. He removed another panel and tried again. The result was identical. "Standardized parts," Hoffmann muttered. "Complete standardization. Every aircraft must be identical. Every component interchangeable." This was a concept German engineers understood in theory, but had never fully achieved in practice. German aircraft were built to standardized designs, yes, but individual components still required fitting, filing, and adjustment. No two Messerschmitts were ever truly identical. Each one had its own subtle variations, its own personality, born from the hands of the craftsmen who assembled it. But this American bomber was different. It was built from components, so precisely manufactured that no fitting was needed at all. They were simply assembled, like pieces of mechanical puzzle, like building blocks. The fuel system revealed even more unsettling truths. The B-17 carried 9 fuel tanks with a total capacity exceeding 2,500 gallons. But it was not the sheer volume that shocked the engineers. It was how those tanks were built. Every single fuel tank was self-sealing. When bullets from a German fighter struck them, fuel did not pour out in a catastrophic fireball. Instead, the tank walls were made of multiple layers of special rubber compounds that swell when exposed to fuel, automatically sealing any holes. The technology itself was not new. Germany had experimented with similar systems, but installing it in every tank on every aircraft had always been considered impossibly expensive and impractical. The Americans had done it anyway. Engineer Klaus Muller spent 3 hours examining the self-sealing tanks. He deliberately punctured one to simulate battle damage. The rubber layers expanded and sealed the hole within seconds. He punctured it again. The same thing happened. Then he carefully counted the layers in the tank wall. 7 distinct layers. Outer aluminum skin, vulcanized rubber, nylon fabric, more rubber, inner aluminum. Each layer bonded precisely to the next. The material cost alone must be enormous, Muller said quietly to Koch. Each tank is more complex than some of our entire aircraft systems, and they have 9 of them. 9. Koch nodded slowly. He was beginning to grasp something terrifying. The Americans were not trying to build cheap aircraft. They were building expensive aircraft cheaply. There was a profound difference between the two. The hydraulic system was triply redundant. 3 independent systems where one would normally be sufficient. If one failed, the aircraft kept flying. If 2 failed, the aircraft still kept flying. The oxygen system was doubled. The electrical system had backup generators. The control cables were routed redundantly through different paths. Every critical system had backups, and then backups for the backups. This was not efficiency. This was extreme over-engineering. This was throwing money, material, and industrial power at every problem until the problem simply ceased to exist through sheer excess of solutions. And yet, the aircraft was not heavy. It was not slow or sluggish. Its empty weight was comparable to German bombers of similar size and capacity. Somehow, the Americans had added all this redundancy, all this safety, all this survivability, without paying a significant penalty in weight. Engineer Hans Dortmann examined the supercharger system on one of the Wright Cyclone engines. Each engine produced around 1,200 horsepower at altitude. The supercharger design was elegant, efficient, and manufactured with astonishing quality. The turbine blades were precision cast. The housings were machined to tolerances equal to, and in some cases finer than, the best German equipment. This is not crude, Dortmann said quietly. This is not inferior. This equals our best work. In some aspects, it may even surpass it. He paused, doing calculations in his head. If they can build engines like this in quantity, in the numbers required to power heavy bombers on this scale, then their industrial capacity is far beyond anything we've been told. The electrical system revealed another layer of industrial genius. Standardized connectors were used throughout the aircraft. Every electrical connection used the same type of plug. A damaged component could be removed and replaced in minutes without cutting wires, without soldering, without improvisation. Simply unplug, remove, replace, reconnect. The radio equipment was modular. The gun sights were modular. The oxygen regulators were modular. Everything was designed to be swapped quickly by relatively unskilled personnel. German aircraft required skilled technicians for most repairs. Every fix was custom work, carefully performed by trained specialists. The Americans, however, had designed an aircraft that could be maintained by ordinary mechanics with basic training. They have thought of everything, Koch said quietly. This is not just an aircraft. This is an entire system. Design, production, operation, maintenance, repair. They have integrated every phase into a single coherent whole. But the most devastating discovery came on the second day of the examination. Engineer Otto Brandt was working in the cockpit area, photographing the instrument panels for later study. He noticed small metal stamps on various components, inspection stamps similar to those used on German aircraft. Normally, these recorded which technician had inspected a part and when. He had seen such markings countless times before. But these American stamps were different. They carried dates, exact dates, manufacture dates, component production dates, subassembly dates, and final assembly dates. Brandt began recording them methodically, not entirely sure why, but guided by the instincts of a meticulous engineer who sensed that these markings meant something important. It took him 4 hours to catalog every date stamp he could find throughout the aircraft. When he finally compiled his notes, he sat completely still for several minutes, staring at the numbers, rechecking his work, convinced he must have made a mistake. But he had not. The earliest date stamp anywhere on the aircraft was February 23, 1943. The latest date stamp was March 13, 1943. 18 days. The entire aircraft, from raw materials to a completed heavy bomber ready for combat, had been built in 18 days. Brandt brought his findings to Koch immediately. Koch reviewed the data once, then again, then a third time. He called in other engineers to verify it. They examined more stamps, more components, more dates. The timeline remained consistent throughout the entire aircraft, 18 days from start to finish. Friedrich Koch had spent 30 years in aviation engineering. He knew what was possible and what was not. He knew how long it took to build an aircraft. He understood the time required for precision machining, for quality control, for testing, for validation. 18 days was impossible, except that it had happened. The proof was stamped permanently into the metal. Koch did the calculations. A comparable German bomber, the Heinkel He-177, required approximately 24 weeks to build, 168 days. The Americans were building aircraft of similar complexity in 18 days. That was a production advantage of 9-to-1. 9 American bombers for every German bomber. But it was worse, far worse. If the Americans could build a bomber this complex in 18 days, how many could they build in a year? Koch calculated conservatively, assuming inefficiencies, downtime, and retooling. Even with cautious estimates, a single American factory could produce over 1,000 heavy bombers per year. How many factories did the United States have? German intelligence reported at least a dozen major aircraft manufacturing facilities. Probably more. If each factory produced 1,000 bombers annually, that meant 12,000 heavy bombers every year. Year after year, without end. The Luftwaffe's entire bomber force numbered fewer than 2,000 aircraft, and German production was already slowing due to raw material shortages and the growing effectiveness of Allied bombing on German factories. Koch sat down heavily. His hands were trembling. "We cannot win this war," he said aloud. "It is mathematically impossible." The other engineers gathered around him. Many of them had reached the same conclusion independently. The evidence was overwhelming. The Americans possessed an industrial capacity that Germany could not match, could not counter, and could scarcely even comprehend. Werner Hoffmann finally spoke the question that hung in the air. Should we report this truth? Koch considered the consequences. Reporting to Göring that German engineering was not superior. Reporting that American industrial power was unstoppable. Reporting that the war was already lost, and that continuing it would only multiply German casualties and destruction. After long silence, Koch said quietly, "We must report accurately. We are engineers. We report facts." Over the next 3 days, Friedrich Koch wrote the most devastating technical report of his career. It was 47 pages long, filled with measurements, photographs, calculations, and conclusions. The language was precise, technical, and mercilessly honest. The report documented every aspect of the B-17's construction. It praised its engineering excellence. It described its production efficiency. It calculated production rates. It estimated American manufacturing capacity. And it ended with a conclusion that would haunt Koch for the rest of his life. The Boeing B-17 Flying Fortress represents a level of mass production engineering that Germany cannot currently achieve and is unlikely to achieve within any relevant time frame. The aircraft construction demonstrates that American industrial capacity is far beyond previous intelligence estimates. If the production rates indicated by inspection stamps are consistent across the American bomber fleet, then the Luftwaffe faces a quantitative disadvantage that no degree of pilot skill or tactical innovation can overcome. We are not fighting an air force. We are fighting an assembly line, and the assembly line is winning. Koch submitted the report through official channels. It reached Göring's headquarters within a week. The response was immediate and furious. Göring rejected the report outright. He denounced it as defeatist propaganda. He demanded a new report that focused on weaknesses and vulnerabilities. He wanted solutions, not problems. He wanted confirmation of German superiority, not documentation of American strength. Koch was ordered to revise his conclusions. He refused. The refusal nearly cost him his life. In Nazi Germany, defeatism was treason. Undermining morale was treason. Contradicting the Reichsmarschall was unquestionably treason. But Koch had allies. Other engineers supported his findings. The evidence was undeniable. And more importantly, Albert Speer, Minister of Armaments and War Production, understood exactly what the report meant. Speer was a realist. He knew Germany's production capacity was already stretched to the breaking point. He knew the war was consuming resources faster than they could be replaced. Speer intervened. Koch was not arrested, but his report was classified at the highest possible level and buried in the archives, where it could not damage morale or contradict official propaganda. A sanitized version was produced for limited circulation. This version acknowledged American manufacturing ability, but minimized its significance. It emphasized remaining German advantages in fighter aircraft. It suggested tactical adjustments. It preserved the illusion that Germany could still win the air war through superior skill, discipline, and determination. The truth was locked away behind classified files and sealed archives. But the engineers at Rechlin knew it. 500 of Germany's finest aviation minds had examined the B-17 flying fortress. 500 engineers had independently reached the same conclusion. The war was already lost. Germany simply did not possess the industrial capacity required to compete with American production. Some of those engineers began to sabotage their own work quietly, not openly, not criminally, not in ways that would bring immediate suspicion, but subtly. They slowed development programs. They recommended overly cautious designs. They introduced technical complexities that delayed manufacturing timelines. They were no longer working to help Germany win. They were working to help Germany survive until the inevitable end arrived. Others resigned themselves to their roles. They continued their duties knowing the outcome was predetermined. They designed aircraft that would never be built in sufficient numbers. They refined systems that would never alter the course of the war. They carried out engineering tasks while understanding that the real war was being decided thousands of kilometers away, inside American factories they would never see. Friedrich Koch continued working at Rechlin until 1944, when Allied bombing made the facility too dangerous to operate effectively. He was then transferred to underground facilities in Bavaria, where aircraft development continued under increasingly desperate conditions. He never forgot that day in March 1943, when he climbed into an American bomber and understood that Germany had already lost. The B-17 itself remained at Rechlin for several months, used for ongoing testing and analysis. German fighter pilots practiced attack runs against it. German gunners tested their weapons against its armor. German intelligence officers photographed every detail for training and documentation. Eventually, the aircraft was destroyed during an Allied bombing raid. The irony was unmistakable to those who had studied it. An American bomber destroyed by American bombers. The circle was complete. After the war, Friedrich Koch was among the German engineers interrogated by Allied intelligence. He was questioned about German technology, German production methods, German capabilities, and hidden projects. He answered everything honestly and in full. At one point, an American intelligence officer asked him when he had first known that Germany would lose a war. Koch's reply was immediate. March 17, 1943, the day I examined your B-17 flying fortress. The American officer was puzzled. What made you so certain? Koch smiled sadly. The date stamps. When I realized you could build that aircraft in 18 days, I knew we were doomed. We needed 6 months to build something comparable. The mathematics were simple. 9 of yours for every one of ours. We could not win a war of attrition against those numbers. Why didn't you tell your superiors? The officer asked. I did. I wrote a detailed report. It was classified and buried. The truth was considered too dangerous for German morale. The officer wrote notes, then looked up again. Did other engineers agree with your assessment? All of them, Koch answered. Every engineer who examined that aircraft reached the same conclusion. We all knew. In 1943, we already knew Germany could not win, but saying so publicly meant death. The interrogation report containing Koch's testimony was itself classified for decades. The American military did not wish to reveal how effectively their industrial capacity had demoralized German technical experts. It was a strategic advantage worth protecting. Koch returned to civilian life in post-war Germany. He worked for several automotive companies, applying his aviation engineering experience to automobile design. He lived quietly and rarely spoke about the war. In 1968, a historian researching German aviation technology located Koch and requested an interview. Koch was 72 years old, retired, and finally willing to speak openly. The interview lasted 6 hours. Koch described the B-17 examination in extraordinary detail. He explained the technical discoveries. He spoke about the psychological impact it had on German engineers. He revealed the existence of his classified report and its conclusions. We were told American engineering was inferior, Koch said. We were told American industry produced quantity without quality. Every word was a lie. Or perhaps those who told us the lies believed them themselves. Either way, the result was the same. We entered a war we could not win against an enemy we did not understand. The historian asked whether Koch felt responsible for Germany's defeat. No, Koch replied. The defeat was inevitable regardless of what I knew or reported. If anything, I feel responsible for not speaking more forcefully, for not insisting that the truth be heard. Perhaps if enough technical experts had united and demanded an honest assessment, the war might have ended sooner. Perhaps millions of lives might have been saved. But we were cowards. We hid behind our technical work and allowed politicians to make decisions based on false information. He paused, his old hands trembling slightly. That is my true guilt. Not that Germany lost, but that I knew the truth and did not fight hard enough to make it matter. The historian's interview was published in a technical journal in 1969. Few people read it. The story of German engineers discovering American industrial superiority through a captured bomber was not the kind of dramatic battlefield narrative that captured public attention. But among historians of technology and military production, the story became deeply significant. It illustrated a fundamental truth about modern warfare. Victory does not always go to the bravest soldiers or the most brilliant generals. It goes to the side that can produce more weapons, more vehicles, more aircraft, more of everything, faster and better than the enemy. The B-17 Flying Fortress embodied that truth. It was not necessarily the most advanced bomber ever designed. It was not the fastest bomber, nor the highest flying, but it was producible. It was maintainable. It was survivable, and most importantly, it was mass-producible at a scale that overwhelmed enemy defenses through sheer numbers. Boeing built more than 12,000 B-17 bombers during World War II. 12,000. Each one constructed in roughly 3 weeks from raw materials to a combat-ready aircraft. Each one equipped with precision engineering, redundant systems, self-sealing fuel tanks, and fully standardized components. German engineers like Friedrich Koch have been completely correct in their assessment. The Luftwaffe never truly had a chance. Not because German pilots lacked courage or skill, not because German aircraft were inferior in design, but because Germany could not match American production rates. For every B-17 that was shot down, 2 more rolled off American assembly lines. The mathematics were simple, and they were merciless. Other German engineers later confirmed Koch's account in the post-war years. Werner Hoffmann, who had examined the standardized components of the B-17, published a technical memoir in 1971 describing his experiences at Rechlin. Otto Brandt, the engineer who discovered the date stamps, gave an interview to a German newspaper in 1975 on the 30th anniversary of the war's end. All of them told the same story. All of them had realized in 1943 that Germany could not win. All of them had been silenced by a regime that could not accept the truth. The legacy of that March day at Rechlin extends far beyond the history of World War II. It represents a turning point in how engineers came to understand their role in warfare. Technical expertise was not only about designing better weapons. It was about understanding production capacity, logistics, economic sustainability, and industrial infrastructure. It was about recognizing that victory depended as much on factories and supply chains as it did on pilots and generals. Post-war Germany absorbed these lessons deeply. The Wirtschaftswunder, the economic miracle that rebuilt the country into an industrial powerhouse, was shaped in part by an understanding of American mass production methods. German engineers studied American manufacturing systems. They adopted assembly line production. They standardized components. They emphasized efficiency and producibility. In a strange and bitter way, the B-17 Flying Fortress taught Germany how to succeed in peace after showing them they could not succeed in war. Friedrich Koch died in 1978 at the age of 82. His obituary mentioned his contributions to automotive engineering, but said nothing about his wartime experiences. After his death, his children discovered the 1943 report among his personal papers. The document had been declassified in 1973 as part of routine archival releases. Koch had kept a personal copy all those years, a silent reminder of the day he understood the truth. The report was eventually donated to the Deutsches Museum in Munich, where it remains in their aviation history collection. Researchers can still request to view it. The 47 pages of technical analysis, measurements, photographs, and devastating conclusions are preserved as a testament to engineering integrity in the face of political pressure. Today, if you visit the National Museum of the United States Air Force in Dayton, Ohio, you can see a restored B-17 Flying Fortress. It stands in a place of honor, one of the most iconic aircraft of World War II. Visitors admire its size, its gun positions, its history of combat missions over Europe. But very few know the story of the German engineers who examined a captured B-17 and realized their nation's defeat was inevitable. Few know about Friedrich Koch's classified report. Few understand that this aircraft represented not only military strength, but industrial supremacy. The B-17 was more than a bomber. It was a declaration. It was proof that American industry could produce precision engineering at mass production speed. It was evidence that wars are won in factories as much as they are won on battlefields. And on one cold morning in March 1943, 500 German engineers saw that evidence with their own eyes and understood that the war was already over. If you found this story compelling, there are countless other moments in history where technology, industry, and human understanding intersected to change the course of events. Stories of engineers and scientists whose work mattered more than they ever imagined. Stories of technical discoveries that reshaped the world. Subscribe to make sure you never miss these remarkable accounts of innovation, realization, and the moments when everything changes.